So, welcome back everyone to our first panel session of this afternoon. For the ones joining us now for the first time, my name is Andreas. I'm the head of the Helmholtz Information and Data Science Academy, the Helmholtz Information and Data Science educational program for postdocs, which organizes this very nice virtual career fair. Great to have you here, everyone from around the world. So I'm especially glad to have with me Dr. Sofia Forslund and Professor Dr. Ralf Mikut, who will discuss in the next 25 minutes together with us on the panel's careers in data science and health. So connecting the great methods and technology that we've been discussing so far all day with the research field, well, health and what we can make best use of that. So we would love for the two of you to briefly introduce yourself and your line of work, and then we get the discussion going on. Sofia, do you want to start out?
Yes, I'll do that. My name is Sofia. I'm originally from Sweden, and I trained first as a biotechnologist and bioinformaticist. I then did a PhD in evolutionary bioinformatics before starting a postdoc at the EMBL in Heidelberg, moving into microbiome research, trying to draw from some of that evolutionary analysis into more clinical questions, and gradually becoming involved in microbiome projects, which is the main focus, I guess, now of the lab I started in Berlin at the Max Delbru Center in 2018. So Max Delbru Center being one of the Helmholtz centers, I'm also affiliated in part with the Charity University Hospital in Berlin. And the focus of our lab is the role of host-microbiome interactions in primarily cardiovascular diseases, but also metabolic diseases, immune diseases, etc., wherein which we try to use high-throughput measurement methods, including metagenomics, as well as various kind of data integration methods to gain a greater understanding into disease biomarkers, with a particular focus on trying to separate direct and indirect factors, including disentangling treatment variables and treatment side effects from causes of a disease.
Wonderful. I'm so excited to learn more about that in a second. Ralf, what about you? What are your scientific focus?
Okay, my name is Ralf Mikut. I'm an engineer by training and moved over the years more in data science. I studied at Technical University in Dresden, moved over University in Freiberg to Karlsruhe Institute of Technology. I'm head of a group doing automated image and data analysis for a lot of different applications, but health was always a core activity in this group. But we are also doing stuff in life science, like other life science disciplines like biology and chemistry, or even engineering applications like energy or manufacturing and data quality aspects in these industry applications. What we are doing is a very wide range of data, starting from video data, image data, with a lot of applications in biology. For instance, high throughput analysis, as Sofia mentioned, play also a big role in this stuff, because all things where you need an automated analysis is necessary to help with data analytics methods. But we are also doing time series data, data from metadata, which are smaller but have to be connected and fused with all the stuff. And one of my functions is head of Helmholtz Information and Data Science School for Health, and I'm the speaker for the KIT, and this is an activity together with the German Cancer Research Center in Heidelberg and the University of Heidelberg. I think this is a short entrance statement.
Well, thank you for paving the way to my second question. As I see, you're both involved in the educational programs in the Helmholtz Information Data Science schools. Maybe you can expand a little bit for the audience what the focus of the HITS for Health and the hybrids is, and what kind of fields the people outside listening to you can expect if they would be interested in joining your program. Ralf, do you want to continue with the HITS for Health?
Okay, as mentioned before, this is an activity of 3 institutions. And all three have different strengths in it, but all are related as well from the data science and from the life science side. For instance, German Cancer Research Center is the biggest research center dealing with cancer in Germany. Of course, with a lot of data science activity inside the center, but also by the school with connections to the computer science faculties of University of Heidelberg and Karlsruhe Institute of Technology. And KIT, Karlsruhe Institute of Technology, has also a lot of life science applications. For instance, in the Helmholtz program, biointerfaces, with a lot of stuff on the interface between biology, chemistry, material science, and this school helped us also to form research projects on this edge between this technology side and this applications. And University of Heidelberg has a very big university hospital, one of the most important also in Germany, of course with close links to German cancer research centers, and also a very strong computer science faculty. And with this constellation, we have three institutions built together to one school that can go forward. And main topics are a lot of imaging and diagnostics, as expected for data science, but also going in stuff like automation and interventions, for instance, with a lot of surgical robots, for instance, and personalized medicine.
Mm-hmm. Amazing, an amazing school you build up there. What about you, Sofia, the grad programs that MDC is involved in? What can we expect there?
Well, primarily, I guess hybrids is the one that we've been mostly playing a part in, which I believe is shared also with other Helmholtz centers. But making use of that is particularly exciting in Berlin, given the presence of both multiple topical universities as well as the Charité and other institutes besides the MDC as well, with a lot of incentives towards collaborations between these centers, in particular clinical versus basic science collaborations. So we would very much welcome further hybrid applications actually for students wanting to follow up further on applied or theoretical data science research in the Berlin research environment. Thus far, I think one of my students is enrolled with it, and we are trying to increase also our participation as well as to build more of a local training infrastructure across centers with courses and seminar series built on primarily health-related data science applications, but this is a slow process as well.
But you guys are hiring, I hear.
Absolutely.
Wonderful. So everyone, after this brief introduction, as always, I would love to refer you to the chat if you have questions for Sofia or hello. So if you have questions for Sofia or Ralf or both of them, post them in the chat, and we'll select the best questions in a second. Let me ask you one question that was discussed when we were talking about aeronautics and space. What kind of background would be most suitable if someone would apply with you, with your group or your school? What should the candidate, what kind of skills should the candidate have? What should the people bring to the table to get involved with your research program? Sofia, you want to start?
Yes. I mean, more important than the technical or educational background, honestly, is drive. So the interest in owning your own research project and the ambition to understand things better, develop new applications. As long as you are having that drive so that you will actively use your own energies towards learning, that is more important than any other aspect. In addition, however, as a data science researcher rather than a wet lab researcher, there is a lot of training time involved unless you already have working knowledge on how to operate a high-performance computing system, basic scripting, basic statistical analysis and data visualization. This can be done, of course, in multiple different ways, but being able to work independently with potentially very weirdly formed and structured data and quickly ask high-dimensional statistical questions of that data is generally an ideal background, as well as anything else that can further a particular application, such as experimental clinical insights. But primarily those two things, drive and substantial computer literacy.
Yeah, interest in the research would be nice, wouldn't it? Ralf, what about you? What would be an ideal background for your program?
Completely agree with Sofia that drive is absolutely necessary to start a career. You need two things in addition. The second one is a reasonable basis. It could become from computer science. It could become from a more mathematical background. We have also good people with a physics background to be open to go in this process of data science. And a second requirement to be open for different application areas, because you have to learn a lot. For instance, no computer scientist normally comes with a deep knowledge in biology or in medicine, and this is normal. And you have to be interested to learn these things and also to understand that these kind of interdisciplinary projects is a kind of challenge, because you have to be familiar in both stuffs and both sides, and to be able to discuss all the aspects with your colleagues with a completely different background.
Yes, that's very much, I feel, what a postdoc is about, learning, actually. Not being afraid to go outside the area you believe you're formally trained in, and to engage with collaborators on their level, because often you will find that they will not know as much as you believe they do, and you may have to carry their load to the completion of a project, and that is possible, and something that I think is more an emotional than a technical challenge.
Mm-hmm. There's one question arising in the chat that I'm particularly interested in as well. I mean, if you think about like more in an old school way, more stereotypical, when I hear health or medical research, I think about a doctor in the clinic and not particularly a computer guy or computer gal. Could you maybe, from your point of view, explain to us how the field of health research has changed in the last, let's say, 10 years because of the new technologies arising? Is the approach just different? What changed in health?
So, do you want to start, Ralf, or should I?
You can start. I can add something maybe later.
I mean, general clinical practice as yet is not connected deeply into high throughput data generation. As far as I can see, it's not standard that any patient that comes into the clinic generates high throughput data that can be used for research purposes. So we're still on the scale that studies have to be designed, planned, funded, applied for with ethics approved, etc. But we have the capacity to realistically make fairly deep phenotyping and deep quantification of subjects within a clinical setting, either observational or cross-sectional, or studying the effects of an intervention, and gain greater insights into how and why this works. So what has changed, I suppose, is mainly the ease and the cost with which we can generate the kind of information that requires advanced data science for making full use of adjacent to clinical practice with greater ease than was previously possible. Hope to change further in that there will be eventually more technical and legal infrastructure in place that allows also routine clinical operations to continuously generate data that would, to my mind, be a game changing what kind of questions we can answer. But the hurdle there is, I think at this point, more regulatory and perhaps habitual is technical.
That's probably right. Okay, so let's have a look in the chat, Victoria. What are the peers interested in particularly?
Yeah, we got some very interesting questions here from our audience. For example, David is asking, other than neural networks, what types of statistical methods are particularly important in your current research?
Maybe I start. I guess you have this complete old basis of statistics, which is quite powerful. For instance, if you think to classifiers, very classical base classifiers are also very strong for a lot of problems, especially if you have reasonable features. And normally we start in any case doing very basic things like base classifiers and polynomial models to see what's the baseline for all more complicated methods. And then you have also some stuff in the direction of decision trees, for the reason if you are able to have decision trees, it's very easy to understand what the algorithms are doing for different steps in between. And only if we see we cannot solve the problem with all this stuff, then we go to more complex stuff like neural networks. And deep neural networks especially have very big advantages and disadvantages. There was an extreme powerful revolution in the accuracy, but nobody understands what they are doing. And I think this is a generation task, really, to get insights and also to be comfortable what these deep neural networks are doing really, and to rely on this information.
Sofia, you want to add to that?
Yeah, I'll agree that at least when it comes to research purposes, I think the situation is different, particularly in exploitation and later translation. We will start with a fairly simple analysis, basic statistical analysis of different kinds. And the reason for this is often that despite the talk of big data, we are often relatively limited in the amount of data we have available, such that results tend to be volatile. Reproducibility between studies is decent sometimes, but not super good, meaning that unless something is robust enough to be visible just by inspection, it's difficult to bring it forward. If you really need a particular type of machine learner to detect a particular signature, is it really something that you want to base patient treatment decisions on at this stage? And I mourn this a bit because I would really like to use complex artificial intelligence techniques also on these questions. But in practice, I think we are not quite at a point where this adds to discovery of novel biology, but it might be very useful in building downstream applications of the discoveries we make. I'm particularly excited right now about different kinds of modeling, particular mixed effect models and Bayesian networks, structural equation modeling.
All right, so there's quite a perspective of utilizing new technology in your field for the future, I hear. Which brings me to another question. I mean, if I take the perspective now of a younger person on the bachelor's and master's level, and I'm more thinking about, let's say, perspective, what I could do in your field. From your point of view, what would you think are the next big things to happen in your line of research? What are the next big milestones to be met? The grand challenges of 2030. So what could I expect to be tackled, to be challenged with if I would join you within the next couple of years? What do you think, Sofia?
So one part is being able to generate data on yet a larger scale, by which I mean particular probands present in studies. This ties into what I mentioned before in overcoming the obstacles to using routinely gathered clinical and omics data for research purposes. Another is to gain more robust and more deep data from each individual traced, more densely time point space data, so that it becomes relevant to try to do more simulation type dynamics. That is one part that I think will become possible, though it will require work, again, primarily regulatory wise, to overcome. Another is that I'm a bit surprised at how fast some of the deep learning techniques are evolving, And there will come a time when we should probably start using them for text mining and literature mining as part of an interpretation of other kinds of results. So this is actually one area where I would like to bring in people at this point, not with a clear application in mind, but because they will perhaps soon reach the threshold where they do become more applicable also for the kind of research we are doing.
Great topics. So what do you think, Ralf? What are the next big things to happen in the next 10 years?
I see two things. The first one, already mentioned a bit from Sofia, is data fusion. For instance, you have image data, you have metadata, you have the complete history of a patient, you have text mining opportunities coming from this background, and bring all the things together really for a decision support. I think it's not solved at the moment, and I guess you will have more decision support direction. For instance, say, okay, have a second opinion for a clinician looking to data, or maybe also to draw the attention of a clinic specialist to say, okay, look to this region, what do you think that it is? And this kind of interaction, I think, is important. And the second one, I guess, is interpretability of all this data science stuff, that you can be sure that you don't hang on artifacts of your training algorithm and have really robust solutions. And I guess there's a lot of ideas for more robustness and for interpretability, for instance, by looking to low-dimensional representations for data and so on. This is also not completely solved. And we have a large gap between nice ideas in theory and the real stable practice use in research and at the end also in the clinics. And we have to close this gap over time.
All right, thank you. That's quite some big steps in front of us. Vicky, we got some more good stuff in the chat.
Yeah, we have a very interesting question from Maria, and she's asking, is epigenomics an ongoing topic for applied data science?
So, epigenetics and data science. Sofia, I see you nodding. You want to comment on that?
Absolutely, absolutely. There are groups at the MDC who are doing epigenomics readouts. We will do some of that, for example, in an upcoming allergy study. It's a little bit costlier than I would prefer to do to run as routine, but to add that as a standard readout along, say, blood metabolomics, stool metagenomics, etc., from patients under as many conditions as possible. And it will be super interesting to see to what extent, for example, successful lifestyle interventions have epigenomic impact. So it's a nice data form to work with, even if not all hurdles are yet worked out. And the more that it becomes routine and costs go down, the more we should add that. I think there's a lot to be found there.
Mm-hmm. All right, so we should, what was his name? To
Maria.
check out Maria. So Maria, check out the MDC. Obviously, there's people working in your field of interest.
We have further questions, and Ashish is asking two questions. And the first one would be, what are your advices for pure computer engineering background people, like practical software engineers, data scientists, to enter research world? And the second question from Ashish is, what is, in your opinion, from the end of research for biomarker finding to evaluate biological age? So very interesting questions. Maybe we can.
So maybe the first one first, what would you suggest somebody purely computer science background who want to enter health? That's actually a very interesting question. How would you approach that?
I jump in this question. I guess really start doing, if you're interested in these kind of, for instance, life science application, go to a group, stay very open what you know and what you don't know, and also have very early hands on the data, talk with people, go to the seminars, and you will understand nothing at the beginning, but go later on and try to add this basic information that you can be able to understand stuff. And I guess if you are very honest and say, okay, I understand these parts I don't understand at the moment, but I'm interested to learn it, you will have also a good start with the life science partners.
All right, so maybe the first step, check out the information booth of the Hits for Health on the fair. And the second question, let's repeat it again for for Sofia.
What is your opinion from your end of research for biomarker finding to evaluate biological age?
So this is an area of ongoing work with a lot of different groups looking at different parts, and I know there's also commercial initiatives aiming at it. There is one technical issue or study design issue and one philosophical issue. The philosophical issue being that perhaps we need to unpack aging not as one single concept, but as a series of separate parts that all are interconnected, that it might be more useful to talk about particular types of cell damage, particular types of developmental dead ends, etc., and that these may be better represented individually. It may also be a challenge to translate this across different model systems, that is to say, animal research on age may be studying in part something different than human aging, though I will point to the interesting work in the naked mole rat as a model organism, both at the Max Delbru Center and also now in Köln. But last, the problem is in getting clinically useful markers, not just for aging-related diseases or frailty, but aging itself. In human, you need a human time scale, so we should probably start already now to biobank subjects ongoing over time, so we can try to tease apart what is wear and tear, what is developmental dead ends, etc. What are the different components? So it's a super interesting and important topic with effort paid to it, but I don't think we have fully phrased it in the most fruitful way yet.
Amazing, an amazing field. Let me ask you one different question, Sofia. I mean, Ralf obviously is from Germany, but you entered the German academia and research world coming from the outside, and in the audience we have way over 2/3 of attendance from international listeners. Is there something that you would share from your experience, what to keep in mind or what to look after when you come from the outside to the German academia world?
So I came in 2012 to EMBL, which, as you know, is not actually Germany. It's a little enclave of international territory in the middle of Germany with its own laws. They, however, provided a lot of help in dealing with the surrounding German society, surrounding bureaucracy, etc., that I found very helpful. And I know there are similar efforts, for example, at the MDC through a welcome center. And I think most universities and centers will have something like this, as in there are people who are paid to help you integrate and function in society, make use of that. I also find that German society works. Coming from Sweden, it works. It functions as predicted. There are structures and procedures for accomplishing things, and it's possible to expend extra effort to push through bureaucratic obstacles. I also find it very safe. At this moment, I'm trying to learn slowly better German for eventual application for citizenship, but I have functioned reasonably well using English a lot of the time. But of course, it's even easier spending some time. If I were doing it again, I would actually do more intensive German learning at the very onset. As for the academic system, I have little experience of the university world, as I've only been in research institutes. And I think the hierarchies and the administrations might be a little bit more labyrinthine in a distributed university setting than they are in a center. But it's still the same thing as anywhere. Find a person who is actually working on something and go bug them about it, because then they get to do what they're good at and you get to do what you're good at.
Wonderful. Ralf, you want to add really quickly what can we suggest international interesting people interested in your school coming from international background?
I guess be authentic, because I guess the society, at least in a university environment, is quite open, and is also it's normal to come from outside and also to keep your own culture. Don't try to be more Germans than the Germans, I guess. That's a good recommendation. And
Great.
what you need for language skills, you come very perfectly clear in university environment with English, but if you want to go outside the university and academics world, it's very useful to learn German in the university world. You don't need it really, because everybody speaks reasonable English. But I guess if you are interested to stay longer, German is a good idea to learn it, especially for the social side.
Wonderful. All right. So everybody, don't be afraid of the language. You can learn it basically for fun, and everybody is perfectly able to speak to you in something understandable to you. This concludes our session. Let me thank the speakers. I mean, you would have a big auditorium clapping to you, but now it's only me. Ralf, Sofia, it was an excellent experience having you with us. To everybody listening, please check out the booths of the Max Delbru Center, of the KIT, and of the DKFZ and all the associated schools. We end this session right now. Thank you so much for joining and attending. Use the chat, use the booths, and we'll come back here in very briefly, 3.5 minutes for the next session of Careers in Data Science and Energy. See you later, guys. Thank you a lot. Bye-bye.
Perfect. Thank you so much.
It was fun, I think.
Yes.